but I've already hit it, and we are up and running. Okay. So you now have 3 assignments since we've last met that you may need to ask questions about. So you may not, I don't know if you're ready for this, but let's see, let's go to, does anybody have any questions on the 2-1 assignment?
Wait, the 2-1 assignment?
Yeah. Last Wednesday, we went through 2-1 and 2-2. I gave you assignments on those 2.
That's the, hold on, let me see if I wrote that down right. Okay, the 1 through 71. Oh, I had already done that. Okay, yeah, I didn't have any questions for that.
Anybody?
I was at 2-2, but.
Then how about 2-2?
2-2. I did. I had a question on number 11. So I checked my answer, and I think I did it wrong. Well, I know I did it wrong because I checked my answer, and my answer was wrong.
Okay.
Could you, like, I guess, show me an example of how to do number 11 so that way I'm...
That's what I will try to do.
Okay.
So number 11. So they were wondering, is B, and oh yeah, and they've used that symbol incorrectly there. Is B an improper subset of A intersect B? Yeah, I wish I should not have given you those in that section because
I don't have number 11 written down as part of the assignment.
Oh, okay.
I could be wrong, but
no,
I don't.
Let me take a look. I got it right here. You're right. It's not.
Oh.
See the assignment? You weren't supposed to do 9 or 13, and you were supposed to do every multiple of 4. So 1, 5, not 9, not 11. I'm sorry, not 9, not 13. The next one you would have had would be 17. So that section that you're asking about is not in there. And the reason I didn't include it is because it's got sets inside of sets, which is just, I didn't teach about that. So
okay, never mind.
You're right. That would have thrown you for a little bit of a loop. Yeah. Anybody else on 2-2?
Well, I had a mark on 17, but I'm not sure if I figured it out.
Okay.
Does this have to be in the union?
But which part, A or B?
I think B. Let me see. Okay, I don't understand my notes, so we can move on.
Okay. So anyway, I did, here's 17B done with, with letters. A complement is BDF, B complement is AC, and you can take the union of that and you get A, B, C, D, F. So I don't know if that helps, but there's 17B.
Oh, okay. All right. So is it important to put them in that order?
No, it's not. I put them in that order because it was alphabetical. All it has to be is that you have those 5 letters in your set.
Okay.
So no, they do not have to be in that order.
Okay. Okay. Yes, I got that.
Oh, good.
I got that one.
Anybody else on 2.2?
Oh, 29.
All right.
Oh, actually, 29, I think I did figure out, but I had a problem with 29, 33, and 37, but 37, I just could not come to grips with that answer.
All right. Oh, well, okay. Yeah, a complement, complement. Okay. So, yeah, let's see. How can I explain that to you? Let me make a little drawing, and I think that might do it. Okay. So,
Okay, is this 37 or 29 you're on? 37?
you said 37 you wanted to talk about.
Right, right. Uh-huh.
So here's the picture. We got a universal set on the outside. We've got a set A. Where is a complement?
Everything outside of the A?
Yeah, I'm not going to sketch it in, but it would be all of that around the outside of A.
Mm-hmm.
Okay. So where's the opposite of that? I mean, yeah, exactly. And that's the answer. That's the answer to the problem. It's A. So it's like what's the opposite of the opposite of A? It's kind of like in math, have you ever seen this where you have a -1 and then you're supposed to take the opposite of that?
Mm-hmm.
And it winds up being 1?
Mm-hmm.
In a way, when you take a complement and take the complement of that, the one, let me get rid of the pictures here, my fault. But the one, so what you're saying is one complement undoes the other.
Okay. Okay.
As far as 29 is concerned, yeah, 29 is what's the opposite of the empty set? So if you take a set with nothing in it, what's the opposite of that? Everything. And so the answer is the universal set. So
okay. Yeah, the second time, well, when I looked at that today, it made sense, but when I was doing the homework, it did not.
Yep.
I don't know how that works.
You point out an interesting fact that sometimes a different day will give you a different outcome. Yeah,
Yep.
That's a good point. And sometimes you need to step away and come back if possible. Yeah.
So what? I'm sorry. What was the answer for 29?
That script you see on the screen
Okay.
there.
Mm-hmm.
Yeah. In other words, everything, the universal set.
Okay.
So the opposite of nothing is kind of everything. Yeah. Okay. How about this last lesson, the 2-3 assignment?
Okay. 2-3. Did you do 9 in class?
I don't know, but let's
Okay.
take a look at it. Let's take a look at it here.
Oh, that one made sense today too, even though it didn't make sense when I did the homework.
Oh, okay. So do you want me to go through it?
Yeah. Could you for me at least?
Oh, you could. Sure.
Okay, so here's the picture on the screen, and the problem number 9 is written at the top there. So we're supposed to do A, remove B union C. So we got to do what's in parentheses first, right? B union C. So B is this part right here. 2, 3, 6, 7. C is 4, 5, 6, 7. And what's the union of those two? So now you got to put them together and throw out repeats. So you get what? 2, 3, 4, 5, 6, 7. Does everybody see that?
Yes.
Okay. So now what's in, so now you go to part, what it says here is step 2. Here's what's in A. 1357. And now we're going to remove that answer we just had up here. So if you start with 1357 and you take out a 2, a 3, a 4, a 5, a 6, and a 7, all you're left with is a 1.
Okay.
Yep. So a set with just a 1 in it is the answer. Anybody have a different one on lesson 2-3 that you would like to go through? Well, it's, if your no question, if your lack of questions is an indication of how well you got it, I'm encouraged. But you know, speak up if you are unsure about a problem.
Okay, how about 13?
All right. So here is number 13. So what's the first thing you got to do on that problem?
13.
You really have to concentrate on this part right here first, the A union B complement.
Mm-hmm.
And what is B complement? Everything not in circle B. So that would be 1, 4, 5. Don't forget about 8, by the way. 1, 4, 5, 8. And now I have to unite that to A. And that gives me 1, 3, 4, 5, 7, 8. And now I can finally intersect with C. So intersect with, I guess I never did mark set C over here. C is 4, 5, 6, 7. So now what's in common between those? 4, 5, 7.
Okay, 4, 5, 7. Okay.
Well, it sounds like, yeah, I'm getting the impression that you guys seem to get what's going on with these new operations, with union, with complement, with intersection, and with that removal, that subtraction. Okay. Anybody else? Question?
I think I'll know more when you can maybe look at my notebook too. I guess I want to make sure I'm showing everything I'm supposed to show. So I might ask to take 2 minutes to look at mine too.
Right.
I'm hearing somebody talk in the background.
Yeah, me too.
Oh, that's sorry. My husband is talking. They're still
that's,
FaceTiming. Oh, sorry.
Okay. Sorry about that.
No,
right.
don't be sorry. So thank you.
Yeah, thank you. Yeah, otherwise we're going to get in on that Florida conversation. I think you said Florida. So, and we probably shouldn't be in on that. All right. So here we go with lesson 2-4. This is the only lesson that is part of our instruction tonight, or today, I should say. Lesson 2.4, and it's it's the title that's in the book. The number of elements in a set. A problem-solving tool. So I don't know how many of you. I forgive me if I make a total misestimate here on age. Okay. But I remember sometime years ago, I remember there was on children's television this Dracula creature, and he was called the Count.
Mm-hmm.
And the Count always had the count of however many of whatever. It was a kids programming. Well, this is the count. This is the Count's lesson, because it's just literally a count of how many items are in a set. And it's an incredibly powerful thing. So anyway, the picture, we can bypass. I just wanted to show you that, for example, the set of odd numbers is shown in the circle on the left, the set on the left, those are all odds. On the right, that right circle is the number of, those are the prime numbers. Prime numbers are any number that can't be divided by any other number other than, so you can see it's mostly even numbers that are left on the outside. They're not prime or odd. 2 is the only prime that's even. Anyway, we're going to be looking at sets that have different I guess that's just a graphic to get us going, so we don't have to worry about that too much. So here's the first real slide where you want to take some notes. Okay. And actually, there's something that's not on here. There's 2 kinds of numbers that you probably have not heard of. And I'm writing them on the bottom. There's a cardinal number, and there are ordinal numbers. And I'm going to just explain the difference between those two, okay? A cardinal number is simply how many, okay? So if you had, let's say your son or your friend was on a softball team and there were 15 guys on the team, then the cardinal number for that team is 15. That's how many players there are. But an ordinal number might be that softball team at the current time is in 3rd place. That three from the 3rd is not telling you how many, it's telling you what order is their team in the standings. So we don't normally differentiate between those two, but do you see the difference between them?
So a cardinal number is the number that it is.
That's correct. And an ordinal number simply refers to what order something might be in. Or number, if you're at the, I don't do this anymore, but let's say you're at the delicatessen and you're waiting to order some cheese, and maybe they made you all take a number. And your number might be 37. Okay, that's an ordinal number because it's telling you, oh, you go after number 36.
Okay.
So that's it. It's not more complicated than that. All right. So now on the rest of the slide, I've got an example. Set A has the elements 1, 7, 10, and 12. And as you can see, set B has the elements 7, 11, and 12. Now here's for the first time you're seeing this notation right here that I'm circling, that says the cardinal number for set A is 4. So when you write a little n with the set name in parentheses, that means the cardinal number. The cardinal number of set A is 4, and all that means is 4 has 4 elements in it. How many numbers does set A have? 4. Okay? All right. Now let's look at this other example. A intersect B. So this is a little bit of a review question. Remember how to do intersection? Intersection is how many elements are, what elements are in common, and it's 7 and 12. So if you look down at the bottom here, we could say the cardinal number for A intersect B is 2 because A intersect B has how many elements in it?
2.
Yep. So it's just this new term that the count would be happy with. It's the count, the number of elements in a set. I can just hear him. The count, he'd be counting.
Mhm.
So the cardinal number of each set. So we've got two. You've heard me use the term cardinal number. Sometimes they'll refer to it as the cardinality of set A is 4. So you'll see two different forms of the term, but it refers to the same thing. All right. Everybody had a chance with that one?
Yeah.
The next one. Okay. So now I've got a picture here with a universal set, and capital A sets capital A and capital B are intersecting. And you can see I've got little small letter elements in a number all over the place. Okay. So I think you would agree, if you look down here, that set A has A, B, C, and E in it, right?
Mm.
Does that look correct?
Yes.
Okay. So what's the cardinal number for set A?
4.
4.
Yep, up in the top right there. Element B, set B has A, B, G, H. What's the cardinal number for set B?
4. 4.
Yep, that's correct. How many elements does A complement have in it? A complement. What does A complement mean?
Oh, everything else. So, so then you would take everything that's not in A.
That is correct.
1, 2, 3. So 3.
No.
Is this F part of it?
4.
Yeah. Did you forget F when you counted 3? Yep. Yep. Okay, so you got 1, 2, 3, 4. Yeah. Okay. So now, in your mind, what's A union B? Well, in the picture, it's everything that's in the two circles, right? A union B would be what? The inside of the MasterCard symbol, so to speak?
Mm-hmm.
Okay, how many elements? So what's the cardinal number for A union B?
2.
6.
That would be, who said 2?
I did.
That would be the answer to the intersection.
Oh.
But how many are in the union?
6.
Right.
Okay.
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 So this is partly review from what we've done before, and now we're just adding this count feature.
So why do you have that F up there in the corner? Just
Set F is an element that's in the universal set, but it's not in set A or set B.
same with D.
Same with D.
Okay.
Why is it up on the top? It doesn't
Yeah,
matter.
that's what I was wondering. Oh, okay.
It's just that it's outside those two circles, but still inside the box.
Mm-hmm.
That's all.
Okay.
I could have put the F anywhere. Why did I put it up there? I don't know. It doesn't matter. Yep. All right, let's go to the next. So, if you have your books handy, I'm going to ask you to open your books up to page 84. So, look to the very bottom of page 84. Okay, you see where it says example 1 on the bottom?
Mm-hmm.
Yes.
Okay, example 1, TOEFL and TSE. Those are two different tests of foreign language skills. When someone comes to America to go to school, they need to take the TOEFL or TSE to find out how good they are at English. So, in a particular school, 800 students are registered for TOEFL, and 500 are registered for TSE, and 200 are registered for both. So, what you now look at the screen I've sent you, and you can see I've drawn a universal set, and I've drawn TOEFL and TSE so that they intersect. Okay. How do I take these numbers? 800 for TOEFL, 500 for TSE, and 200 for both. How do I get those numbers in there and have them make sense? What number do I need to put in first?
Would it be the intersecting number?
That is
Would it be
correct.
200?
Okay.
Okay.
That is correct. That was a very good answer. Now, so now that affects us, because when we put in that TOEFL has 800, can you see that I have to write it this way?
Not really. I don't see why you have to write it that way.
Okay, well, okay,
go ahead.
Let me show you here's what I meant by that. Does this work? Does that work that way? No, because now how many do I have in TOEFL?
Oh, okay. I see it now. Yes.
Yeah, okay. So that's why it's really important that we begin with the intersecting part. So now we know, all right, TOEFL has 800, so that means there must be 600 in that part that doesn't overlap. And TSE has 500. So what do I write over here?
300.
Oh.
It's got to be 300, right? Now you can answer the questions on the bottom. What's the total number of registered students?
1,100.
Correct. How many students are taking TSE only?
Oh, 300.
Yep. And how many are taking TOEFL only?
600.
Excellent. So this is all I know, fairly simple, but this is all part of knowing this cardinal number in a set. Okay. Now, these are some of my favorite examples in the book. You'll forgive me if I'm like really, I just love these problems. Okay. So here's example 4, and it's in your book if you want to look, but I've got a copy of it here. It's a music survey. A survey of students at Princeton University shows that 29 like jazz, 23 like rock, 40 like classical music, 10 like classical and jazz, 13 like classical and rock, 5 like rock and jazz, and 3 like all 3. If there are a total of 70 students in the survey, find, okay, then we got some questions. So what I did is I made a universal set, and I made 3 circles: J for jazz, R for rock, C for classical. And I have to draw them so that they all intersect. Okay, so based on the really good judgment you used in this example we just did a few minutes ago, where do we need to begin in filling this out?
With the 3 that like jazz, rock, and classical.
Exactly. And that would have to go in that position, correct?
Right.
Because that's the only place where all 3 overlap. All right. So basically, start on the bottom and work your way up. Now that we've done the 3, and that's the only 3, let's start doing what? The 2s. So next, let's do that one. 5 like rock and jazz. Well, so in your picture, where do rock and jazz, where do those 2 circles intersect?
At the top?
Right above that?
Right above
Well-
the 3?
Well, isn't this whole thing where they intersect?
Yeah.
That I've highlighted?
Yes.
Okay. So what this is saying is we need to have a total of 5 in there. Okay. So what does that lead us to do?
2? Okay.
Yeah. So do you see how I got that?
Oh, okay.
Because the whole overlap has to be 5. Okay.
Oh. Gotcha. Okay.
Now let's go to this one. 13 like classical and rock. Where do classical and rock intersect? Well, I'm going to change
The
colors.
left of 3. Or to the right of the 3.
This is where classical and rock intersect, right? That whole thing.
Mm-hmm.
And that needs to total 13. So what does that lead us to if that's supposed to be a total of 13?
10. 10 in the space.
Yep, you got the picture now. And then let's go to this next one. 10 like classical and jazz. Where do classical and jazz overlap?
The other side
To the 3.
of the 3.
And so what does that need if that's supposed to total 10?
That's 7?
That's correct. Okay. So now we're down to the singles. 40 like classical. How many do we already have in the classical circle?
20.
Right. And so we need
20.
20 more to make it a total of 40. Are you guys all following this?
Yes.
Excellent. Good. And then 23 like rock. How many do we already have that like rock?
15.
Right. So what do we need in the outside of that R circle?
17. Oh, wait a minute.
15 plus 8. 15 plus 8 is 23. So we need 8 there, right?
Okay.
All right. And then 29 like jazz. Currently, how many do we have that like jazz?
12.
Right. So we need another
37 or 17.
17 added on to 12 would be 29.
Okay.
Okay, well, we're almost done. But now I need you to look right here. In the problem, it says there's a total of 70 students that took the survey. I need to add up all the numbers I have in there because, you know what? Well, let's just do it. Add up the numbers in all. Let's add up all the numbers we've put up there. 17 plus 2 is 19. Plus 8 is 27. Plus 10 is 37. Plus 3 is 40. 47. Plus 20 is 67. So the total right now is 67. And this right here says 70. What does that tell us? Where are the unaccounted? That's right. The 3 that we're missing at the moment have to go on the, does everybody see they have to go on the outside?
Mm-hmm.
Okay.
Now we've got the problem solved. So part A, what's the number of students who like classical music only?
20. Oh, wait
What?
a minute.
What's the number of students who like jazz and rock, but not classical?
Oh.
Be careful. Jazz and rock would be in that red section, right?
Mm-hmm.
But not classical.
2?
You bet.
Oh, okay.
And part C, the number of students who like jazz, rock, or classical. Who do not like all 3. They do not like jazz, rock, and they don't like classical either.
That would be 3.
That would be that 3. Yep.
Okay.
So did you guys follow how to do that?
I follow it.
Okay. We're going to do another one. Similar. But does anybody need time on this slide yet?
No, I'm good.
Okay. Yeah. Okay, this is kind of funny, I think. So this is at a college, and it's about students enrolling for 9 a.m., 10 a.m., and 11 a.m. classes. Okay? This is what I think is funny. Check this out. Mr. Enroll, registrar. Oh, ha, ha. Not pretty funny, I think. Anyway, so now the problem is we have a 9 a.m., a 10 a.m., and 11 a.m. class, and I didn't want to call them this. I didn't want to label the circles by the number because the numbers would be confusing because we're using numbers for other. So I called the 9 a.m. circle N, the 10 a.m. circle T, the 11 E. Does that make sense?
Yes.
Okay. So here it's a percentage thing. 45% of a 9 a.m., et cetera, et cetera, et cetera. Okay. So we need to begin where all of them overlap, right? So here's where we want to look first. 5% have a 9, a 10, and an 11 a.m. class. So 5%, let me change to my red here. 5% goes in there. Okay? Next.
Okay.
15% have a 10 and 11. So you need to look in the picture. Where do T and E intersect?
Right below 5. Well, not right below it, but like kind of to the right of it.
Well, actually they intersect including the 5, right?
Okay.
Yeah.
Yeah. So that has to that red part that I've crudely outlined there has to total 15.
Mm-hmm.
So we have to put a 10 in there, right? Okay. 10% have a 9 a.m. and 11 o'clock class. So 9 and 11, those intersect over here.
It's going to be a 5.
And that has to total 10, so that's got to be 5. Right?
Yep.
And 20, 9, and 10. So this part right here has to total 20. So do you see how I had to put a 15 there?
Right.
Okay, so now let's do the singles. 40% have an 11 a.m. class. So how many are in the 11 a.m. circle already?
15.
20.
No, 20.
20.
Just
Yeah.
kidding.
So we need to do another 20 to get it to total 40.
Mm-hmm.
Okay, how about 10 a.m. class is supposed to have 45 in it. What do we currently have in there?
30.
Yep. So how many do we need to bump it up to 45?
15.
Yeah.
15.
I had a stray mark get in there. Yeah, and you're doing the last one. Good. 45 of a 9 a.m. What do we currently have?
25.
So we need another 20.
Yep.
Now, this is probably when you think you're done, but there's one more step. This time it's a little bit hidden because what should the percents total?
I think 100.
That's
But-
right. You are dead correct. And do they?
No.
Let's check it out. 35, 50, 60, 70, 90. So that leaves 10%. Yep. So that would be the outside. So what percent of students have, now let's answer these two questions. What percent of students have only a 9 a.m. class?
Oh, only 9 a.m.
That's correct.
Oh, is that the 20?
That is what it is. You bet. What percent of students have no classes at 9? They don't have 9, 10, or an 11.
10.
That's correct.
Okay, so when you were counting up to that 100%, were you counting all the numbers in the? Oh, when you got 90, you counted everything in the circle, right?
Right. That is correct. So here, I'll just do it. Yeah, 20 plus 15, 35 plus 15 is 50. 60 with that, these two 5s, 70 plus 20, 90. So we had 10 left. Yep. Okay. So did I hear, was that a fatigue sound I just heard?
Well, it's like a complex. Well, I mean, it makes sense doing it. It just seems, you know, a lot of stuff you make a mistake on.
Yep, that's true. But it's all adding and subtracting. So, you know, you can, you know, I don't care if you use a calculator. Okay. I don't know. Let's see how we doing here. We're on 41. I think we have time for this. All right, let's do one more example and try to really get into this. So this is investors. And we've got 3 categories: utilities, transportation, and bonds. So I have made 3 circles: U for utilities, T for transportation, and B for bonds. Okay. We've got 100 people who invested money. That's what this says right here. So we know that. So now this one's a little different in that you're going to find this a little bit. Anyway, let's just start. We got to start at the bottom, right? Okay. How many owned all 3?
3.
So we start there. Then 10 owned utilities and bonds.
Utility. Okay, to the. Oh.
Let me just, maybe I went too faster, but do you see where do utilities and bonds intersect?
Yeah.
So I had to have that total 10, so that meant that had to be a 7. Okay. Next one, 23. On transportation and bonds. Transportation and bonds. That intersects right here.
The side of the 3, yeah.
So
how many is it now?
20? Yeah, 20.
So that's got to be a 20. Okay. 13. Now it says 13 owned utilities and transportation. Utilities and transportation. That's this part up here.
10. 10?
Yep. Okay, now be a little bit careful. I mean, it's not yet, but it's coming. Watch out. 70 owned bonds. That one is pretty much standard. What can I do to find out where do I put a number to make bonds turn out to be 70?
Bottom.
Bottom, yeah.
And how many?
So you put 40? 40 there?
Yep. Okay. Now, here's where you got to be careful. Look at what this one says. 15 owned transportation only. So what does that mean? It means they're telling you this number.
Okay.
So do you see that instead of saying transportation had 60 in it, and then you had to add up and subtract and put the remainder in, this one's just saying there are 15 that only had transportation. So it's like, this is a break. You could just write it in there. No?
Okay.
When they say only, that means it doesn't, the only part doesn't overlap with anything.
Okay.
wouldn't you agree? This 15 where it's placed, did I put that in a place where it's only transportation? Yes, I did.
Yes.
Because nothing overlaps there. So you see how that was a break?
Okay. Yeah.
So is this one. 5 owned utility stock only.
5 right there. Yep.
Yeah, so watch out. I mean, you got to watch out for that word only there. Do you follow?
Yeah.
And if you get an only, that's kind of a break for you. Okay. All right. So I just want to make a comment. We lesson 2.5, we're going to talk about this next time, but how many elements does set A have on top here? So what's the number of elements in set A?
Infinity.
Yes.
Oh.
And that's what's we're going to talk about next time. And I'll just show you a little video here, which is kind of cute.
Okay, what's the biggest number you can think of?
A trillion, billion, zillion.
That's pretty big. How about you?
10.
Okay. How about you?
Infinity.
Can you top that?
Infinity and 1.
Actually, we were looking for infinity plus infinity. Sorry.
What about infinity times infinity? Oh.
It's not complicated. Bigger is better, and AT&T has the nation's largest.
So, and by the way, we could even do better than that. What's infinity to the infinity power? Anyway, the point is, once you get up to infinity, we run into some interesting problems. And, well, that's just kind of a little precursor of where we're headed next time.
So is this going to be for next next class?
For Wednesday.
For
Yeah.
Wednesday.
You don't have to do anything with that. That's just a little teaser.
And then is this 2-4 also due Wednesday?
Yes.
This assignment? Okay.
Yes. Yeah. And here is the 2-4 assignment. So please note, I want you to do all, 1, 2, 3, 4, and 5. You do all 5 of those. I don't usually have you do evens, but there I'm going to have you do them. And then from 7 to 25, just the odd numbered ones. So I may have buzzed by some of you or any of you. I hope I did not, but let me know. Do you have any questions? No questions. All right. Well, then I guess we're going to sign off until I see you again on Wednesday.
And Wednesday, our notebooks are due?
No, they're not due yet. Let me just go back to the website and let's talk about schedule.
Those are due, I think, in not this Wednesday, but the following.
Following Wednesday. Okay.
Yeah.
That's correct. So you looked at the schedule. I just want to take a quick look at what the schedule shows here. Okay. So this is the week we're currently in. We just finished this lesson 2-4. Okay.
Mm-hmm.
So next week, Wednesday, technically we're into week 3 then. And you can see what's going to happen. I'm going to give you this is going to be a little different. So I'm going to be giving you a presentation for the infinite sets called the 2 infinities. That's this right here. Okay.
Mm-hmm.
And then the rest of the night, we are going to be reviewing the chapter that we have just finished. Okay.
Okay.
So that's it. Then, when it comes to Sunday, Sunday, I'm going to have a review session online, but won't be any new assignments. We're just going to be trying to get ready for this test. Okay.
Okay.
And I would like to encourage you to. We'll talk about this Wednesday night, but you want to start looking at the practice tests in the book. We'll talk about that.
Do you want us to do like, and I guess we'll talk about this too on Wednesday, but I just want to make sure. Do you like, are you okay with us taking like some notes like with us like for the test, or do you want us to just memorize everything?
Yeah, I'm going to have to think about that. For one of the tests, chapter 3, I believe I gave people the option to use their notes one time. So I'm going to have to think about that one, okay?
Okay.
I'll get back to you on Wednesday. And then I just wanted to show you that week 4, you probably guessed it. That's when we take the test. Yeah, and we're going to get a little start into lesson 3.1. And when we take the test, I'm going to start off that Wednesday even with a little bit more review if you want it. Okay? So just to double check. So you can see I'm trying to get you guys ready for a test on sets.
Okay.
So go ahead. Any other questions?
I was just going to ask, typically how many questions are on a test?
Wow. That's hard to say. I mean, it's all designed to be done in approximately 50 minutes normally. Okay? So 50 minutes is the length of our class periods at the college.
Uh-huh.
So normally a test should be able to be done in maybe, most students get done early. So as far as so I think that's a better description than how many questions.
Okay.
Now, if you want to take more time, I'm perfectly okay with that. By the way, I don't give time tests. So I'll practically give you whatever you need. The only restriction is that I think we should all go home and sleep in our beds that night. So we'll have a limit, but I'm not going to sit there with a clock and say, hey, you got this much time left, because I'm trying to take that pressure off of you.
Mm-hmm.
Okay, I think we're hearing all set. Thank you. I will see you on Wednesday night.
Okay, but can I just ask one more thing? Not really a question, but what Daniela asked about the notes. My main concern with notes was the symbols and making sure I remember what they mean. Mm-hmm. So
right, that's right now. I've never done that. I've never let people use notes on this chapter before. I will consider it.
Okay.
But you're right. Symbols is part of what a person has to learn to get ready for this.
Okay.
So that is one of the challenges. You are correct.
Okay.
But I will tell you for sure on Wednesday.
Okay. Sounds good.
Okay. Good night, everybody.
Thank you. Good night.